In this problem, we would like to figure out where is this lost max value in the matrix. So one easy way here is just let's keep iterating on the whole matrix. Here is a couple of rows, a couple of iterations, one over every row, one over every column, and then we have a max value that we are maximizing and the target row and column answer. And here we are saying if max is less than or equal the value, then we got a new value. Now we are sure that this is finding the whole maximum among all of the values here. Now for the last occurrence, if you'd like the last occurrence, then you would like every time you still find a value, even if equal to you, to update your position. That's why we are putting here less than or equal. The less than or equal, when we find here the 10 in the first time, it will be greater than the 1 and 5 and 1. And then when we find this 10, we will use it. And then when we find this 10, we will update. And when we find this 10, we will update. So why are we updating? Because the equality is considered. On the other side, if you would like to find the first occurrence, then all what you need is to just use less than. This way, even if the value is equal, there will be no update. I would like to show you also another trial that I'm trying to get rid of looping style, which is more of a C++ Java style. So the idea is as following. I'm going to flat the matrix. By flattening the matrix, we will convert all of it to a single row with all of the values. We did this before. You iterate over every row, every column, and then you concatenate, you append all of them together. Once we flattened the whole matrix, then the answer should be the argmax, but it should be the argmax of the last one of the first. So now you can think of this list as one big list together. And then this 10 here is an argmax, but we'd like the one that is the last. So let's develop a function for that. If we wanted to implement the argmax first, we did this before. We just need to find the max, then list of index over this max. If you would like to find the last occurrence, you need to do a small change. You can, for example, reverse the whole list and then find the argmax itself. And after that, you can just compute the length minus 1 to flip back the index, because the index coming from here would be the first index in the reversed list. So to reverse this one, you need to reverse it again. Overall, this function is returning the index of the maximum value by the last occurrence. Once we did that, we got now our index, but in a 1D list. If we used our 1D to 2D function, we converted this index to the 2D again. So the overall idea was convert from 2D to 1D, find the last occurrence, return it back to the 1D, to the 2D again. That's all.